Hello everyone, this is Speedrunning AP Calculus A, B, and BC, lesson 1.1 in 3 minutes or less. Can change occur in an instant? First, we have to remember how to find the average rate of change by connecting any two given dots on a function using a secant line. Once we've done this, I can find the change in y and change in x between these 2 points. Now, what I'll define as the change in y divided by the change in x, in this case, is, again, our average rate of change. However, this time, I'm trying to find the change that occurs in an instant, which I will abbreviate as IROC. Now, this is a little bit more difficult to conceptualize because instead of 2 points, like I had previously, I only have 1 point. And how do I draw a secant line or a line with just 1 point? Is my line going to look like this? Look like that? We don't really know, and there doesn't seem to be a clear way of how I can find my change in y over change in x. Now, we might seem stuck, but we're actually not. All we're going to do is modify our previous understanding for the average rate of change, where I found the change in y and divided it by the change in x. Instead of these 2 separate points, what I'm going to do is move my second point so that it becomes extremely close, infinitely close actually, to my first point. When these 2 points are right next to each other, I can once again connect the 2 points. You can sort of eyeball that right here. This is essentially a visual representation of my instantaneous rate of change. In fact, these 2 points get so close together that they essentially merge into one single point mathematically, right? That's how I get my definition for the instantaneous rate of change, which happens at one single instant, rather than the average over a length of time. Now, my instantaneous rate of change is also going to be known as the slope of the tangent line rather than the slope of the secant line. And additionally, this is a fundamental understanding for the rest of Calculus A because the instantaneous rate of change, in other words, can be known as a derivative, which gets a lot more complicated than this, but is essentially the basis for all of Calculus A.